everybody. I'm super excited to introduce our very talented presenters, my colleagues, Dr. Shantanu Tuli and Amir Zaradeen. Shantanu and Amir both work on our data and insights team here at Astronomer and have a wealth of knowledge on data science, data analytics, and Airflow. So their presentation today is going to cover how Airflow can help with data analytics workflows, which is something we haven't dived too much into before in previous webinars. So I'm super excited about it. I think it's going to be really applicable to lots of real world scenarios. And so with that, I will hand it over to them. Take it away, Amir and Shantanu.
Thank you, Kenton, especially for that leg pulling. Hi, everyone. I'm Shantanu Tuli. I work on the data team here at Astronomer as a staff data scientist. And Amir Zaradeen was going to be co-presenting with me today. He's a machine learning intern with the team, and I've had the privilege of working closely with him for the last couple of months. I'll start us off and then hand it over to Amir. So, going into slide share mode. Today we're going to talk about how to use Apache Airflow as a data analyst. And before we get into any details, let's first sort of set the ground around who is a data analyst. I see data analysts as having three core strengths that help them do the awesome work that they do. And this title has many different names across the industry, different companies. So a data analyst is sometimes referred to as a business analyst, business intelligence engineer, analytics engineer, etc. But I think what's core to this role is, first of all, having extensive knowledge of the business and its KPIs. So data analysts really know what the business's vision is, what the objectives are, what metrics can fold up into those key results for the objectives, and what the target values are in order to say whether or not you're successful against an objective. For example, when a new objective is being defined, a data analyst will work with the stakeholders to build those metrics, knowing what data exists and how to use that data to calculate said metrics, and what's possible versus what's not. Just because you want to track a certain attribute of your user behavior doesn't mean that you're equipped to do so, given your data. So that data knowledge is really the second pillar. So data analysts will know the company's data very, very well, and also what data isn't in the company's databases. So not only understanding the ETL and ELT pipelines, the databases, but also what is left out in these pipelines. Let's say I pipeline some data from a microservice, which serves something to my end user. There are decisions that have to be made around what attributes of that data we actually pipeline over to our analytics database, and some things will have to be left out. Otherwise, you might end up with too much data. So a good sense of what isn't being captured is extremely important to this role as well. And finally, sometimes data analysts will have to incorporate data from outside sources. So a sense of what public APIs are out there, public data sources are out there that might complement the business's data, fill in the gaps, and an understanding on how to find relevant sources of data. And the third pillar, in my opinion, is really that domain expertise. So understanding of the business's KPIs and the business's data to inform decision makers in a constructive way, in a way that allows them to make good decisions. So data analysts will analyze the relevant data. They'll actually compute the values of the relevant metrics that they have worked with stakeholders to build. And then they'll visualize and communicate these results. And the audience to whom they communicate the results can vary vastly. They can be technical audiences, non-technical audiences, folks with a high-level view of things, folks who don't have more than 5 seconds to spare on a given topic. So that communication is key, and that's eventually ultimately what helps businesses make good decisions based on data. And then finally, often these analytics and insights will have to be delivered on a regular cadence in a reliable manner. So for example, a dashboard or a report. The data analyst may be responsible for those delivery methods. And then we have to make sure that the data is kept fresh, it's always up to date, and the dashboards are reliable. So these are the broad strengths and functionalities that I regard data analysts as having. And if you find yourself doing a similar or performing a similar workflow for your business, for your company, no matter what your title is, this webinar hopefully will be relevant to you. So briefly about Apache Airflow, I'm sure since you're here attending our webinar, you have some idea of what is Airflow. But in short, it's a tool for programmatically authoring, scheduling, and monitoring data pipelines. It's an open source Apache project. It's core to data pipelining. Many teams across the world already leverage Apache Airflow for pipelining their data. It has a very extensible framework, so that the execution framework will scale as much as you want it to scale, essentially. And Airflow plays really nicely with whatever stack, whatever tool chain you might have. It is a rich ecosystem of provider packages. So again, it plugs and plays very nicely with other tools. And finally, there is a large, vibrant community that maintains and contributes to Apache Airflow. We're constantly blown away and having to update these slides around the numbers, downloads, provider packages, the number of contributors. We have about 2,000 contributors to the open source project. In the last 3-ish months, we have 900 to 1,000 commits to the GitHub project, and a vibrant community, so 22K Slack members. If you're not on the Apache Airflow Slack, consider joining. It's a great place to get your questions answered. So with that, let's pop into a user story for a data analyst. I'll pause briefly for a second and see if there's anything in the chat. Looks good. Kenton, feel free to interrupt me if there's anything. So the user story that we want to tackle here is, as a data analyst, I work for an investment management firm. I help our clients make good decisions about their investment portfolios. So that's my role, that's my job. To do so, I retrieve market data, so stock trading market data regularly. And for each of my clients, I provide an analysis of how the industries that they're invested in are performing. That's the analysis that I perform. I then persist the transformed data and the results from this analysis. I send automated notifications to my clients so that they can take action when necessary based on their the stock movements in their portfolio. And I also keep a dashboard up to date for each client so that they can check their investment health at a glance without, even if there isn't, emergency notification or something that immediately needs to happen. It's just for their gut check. So this is my data analyst user story that Amir and I have, developed a workflow on top of, and we'll keep coming back to this user story to make sure that our workflow makes sense in this context. So the stack that we're going to be demonstrating here today is going to consist of Airflow, Databricks, and Tableau. And we'll outline the strengths of these tools that make them particularly suited for such a stack. So for Airflow, there are likely a lot of existing data engineering pipelines that are already supported within a business that are powered by Airflow. So it's as an analyst or as an analytics engineer, orchestrating my analytics pipeline on the same tool certainly has its benefits. There are tons and tons of Airflow operators and more being added all the time. So no matter what I am looking to do in my workflow and what tools I'm looking to connect with, I'll have options for those. And as an aside, the astronomer registry has all of the operators that are certified operators out there. So if you're looking for an operator for something, more likely than not, a search on the registry will get you that. And then thirdly, as I mentioned earlier, often a part of the data analyst workflow is scheduling these analytics, putting them on a schedule and presenting them somewhere. So Airflow as a workflow orchestrator is perfect for that. Next, Databricks. So Databricks' strengths include the notebook interface, which makes it really easy to sort of to run code against data, because the databases can also be mounted in Databricks. So you have this interface where you can interact live with your data. But also Spark is supported. So if your data is large, or if you need to do map reduce in order to perform your analytics, then that will be natively supported without any extra effort on your part. And then this notebook interface supports Python and SQL and other tools as well. But the point being that you don't have to switch context, you don't have to switch between different tools. And so your database is not only sequestered in a SQL environment, but you can also use Python if you're more comfortable with that, or if you're more comfortable with that, and you can go back and forth within the same notebook interface. And then finally, Tableau. Tableau is also a popular data visualization BI tool. Its strengths include the visualizations are UI based, so relatively little code within the visualization tool itself. You can, once you've connected Tableau to your database, the data will be regularly refreshed and updated, and you can create visualizations on top of that data. And then finally, Tableau is a tool that folks are fairly familiar with. So no matter who the stakeholders are for a given project, it should be relatively straightforward to give them the necessary access to be able to view and explore dashboards. So it's a nice layer to communicate with the stakeholders with, as opposed to something a bit lower level like Databricks or Airflow. So that's why we've chosen this stack, chosen to demonstrate this workflow using this stack. And it's a fairly common stack as well. But of course, it's important to note that you can switch out tools for one another. So certainly with the visualization aspect, instead of Tableau, a different tool could be used, and the same stands for Databricks as well. So what does the workflow look like? For this workflow, we are going to, as I said, we're working with financial data. We're going to be retrieving some data from a stock market API, and we're going to configure parameters for the given clients and their portfolios. And we're going to send that over to Databricks. Within Databricks, we're then going to transform the data, run the analysis, and we're going to do that primarily using Python. If we discover something of note in the data, we will then send notifications to our clients based on that discovery. And regardless, we're going to write our data, our results, transform data into the Delta Lake leveraging Spark. Now, all of these are going to be done in Airflow, done through Airflow. So Airflow is going to allow us to send parameters into Databricks. It's going to, we're going to use Airflow to trigger runs, notebook runs within Databricks. It will then retrieve back data from Databricks and use that to send notifications. And then finally, we're also going to connect Databricks up to Tableau, where leveraging Spark SQL, Tableau is going to be able to connect to the Delta tables and visualize that data. Within Airflow, this is what the DAG might look like. So it has 4 parts essentially. So we're going to, again, use Airflow to trigger the Databricks job. We're going to retrieve the output from the Databricks job. So in between these 2 tasks is the Databricks notebook is running and performing the transformations and analysis. Based on the outputs, results from the Databricks notebook, we're then going to make a decision around whether or not that email notification to the client is necessary. And we're going to use the business logic there around what the stock market is doing. How much has the stock changed based on the previous day, perhaps the previous week? So that decisioning is going to happen within Airflow. And then based on that decision, we'll either send an email or not send an email. So this is a branch operator. You go along one branch or the other, not both. One quick note, so the Apache Airflow logo on the bottom right on this slide indicates that we're currently in Airflow for showing this part of the workflow. For all of the slides going forward, the logo of the tool is going to help you see which tool we're in at any given moment in time as Amir talks through the workflow. And with that, I'm going to hand it over to Amir so that he can go into more detail for the workflow.
Cool. Thank you for that, Shantanu. So let me just set this up here really quickly.
And Shantanu, while Amir is setting that up, we had a somewhat relevant question in the chat that I answered a little bit, but somebody had asked basically why you would use Databricks over like a Jupyter notebook. Do you want to touch on that?
Yeah, that's a really good question. And there are two folds to this answer. First off, yes, you can use a Jupyter notebooks. And in order to orchestrate a Jupyter notebook, in order to orchestrate that, you can still use Airflow using something like Papermill, which will, again, help you run that notebook on a schedule. But to argue for the use of Databricks a little bit, Databricks, one of the nice things about Databricks is that the data is also right there. So once you mount Databricks onto either your cloud storage, whatever solution you're using, or you connect it to your database some other way, the data is within that UI. As you're working in your notebook, you reference it directly, you run queries against it directly, you can see the Spark jobs running, there's good log output to show progress and so on and so forth. So it's a very comprehensive environment to be working in, as opposed to one thing that I run into with Jupyter notebooks is that setting up against my database is a bit harder. And then switching kernels to for Databricks, each cell you can specify which language, which kernel you want to use. I don't think you can do that yet in Jupyter.
Cool. That was a great explanation, Shantanu. Now I will start by diving into the more technical aspect of this workflow. So first off, I'll be more so focusing on how does Airflow actually communicate with Databricks, and more importantly, how can we leverage Airflow with regards to passing parameters over onto or into Databricks. So as you can see over here, so with this example, you're able to utilize the Databricks run now operator, which a more thorough explanation for this operator will be available on the registry. So with this specific example, you can see that we've specified portfolio at the top over here. And this will change from client to client and such. Essentially, it's in the format of a dictionary with the key being stocks, and then you have the values over here being the portfolio in a string that's delimited by a space. Within the Databricks run now operator, how this interacts with Databricks, that it essentially invokes or initiates a job. So within Databricks, you're able to create a job and attach that to a workbook. The Databricks run now operator essentially calls onto this job and tells the job to run whatever notebook's attached to it, as is specified here by the job ID. So once that job is run, what we're also able to leverage here is the notebook params you see at the bottom, where here we're able to specify the variable we'd like to push over, or the data or parameters we'd like to push over onto Databricks. And here we're pushing over the portfolio, which is up here, into the Databricks workbook using the Databricks run now operator. So with this operator, we're both running that job or running that notebook, as well as pushing parameters over into it. As you can see over here, the key being stocks, we're able to, within Databricks, retrieve those parameters, in this case labeled stocks, using this function over here. Within this function, we're able to specify the parameter we'd like to pick up. And in this case, we're picking up that parameter and essentially splitting up that string into a list that is delimited by a comma. So now we have a portfolio that's containing a list of each of these stock names, these stock tickers. Now within Databricks, you're able to actually head over to the job itself and open up the details for that specific run of that job. And you're able to see on the bottom right-hand side over here, we have parameters. And this is essentially the parameters that we fed from Airflow into Databricks. So it's pretty convenient. You can just see, for peace of mind, I guess, in a sense that everything was transferred over properly. This is the data that Databricks receives from Airflow. Now, what to do with this data? So in this specific case, we're tying it in with the metrics. So we want essentially the client to be able to see what their portfolio is, what the health of the portfolio is like. What does their portfolio look like? So in this case, we're going to be focusing on using a Yahoo Finance API, inputting that list of each of these tickers, and retrieving two major pieces of information: the sector for which that company belongs in, as well as the market cap, which is essentially the valuation of that company. So with this specific example, we use this API, fed all of these stocks into it, and retrieved in the form of a dictionary, the key being the actual ticker itself, and the value being a list of the sector as well as the market cap. So to best visualize this, we're going to be focusing on essentially aggregating this data and squishing it down into showing the market cap, or the total market cap, by the sector itself. So essentially, I'll show you the weight. Is your portfolio more so heavy on tech, consumer defensive, real estate, and so forth and so on. So we're doing some transformations over here, and what we're going to be doing is here performing that aggregation, and we're going to be left with a bunch of unique variables, which are the sectors and the sum of the market caps per sector. With this data, we're then going to be pushing it over onto a Delta table within Databricks, and that Databricks natively supports Delta Lake infrastructure and such. And from there on, we're going to be moving on to Delta Lakes and using Delta table to pull the information for us, which will then be pulled into Tableau. So within the Delta table, it's pretty easy to switch over from using a Python data frame and converting that data frame and pushing it into a Delta table. And we do that by utilizing Spark. So in this specific example, you can see in line 2, we transform that pandas data frame into a Spark data frame. And within that Spark data frame, we create or push it onto a Delta table. And in this case, it's going to be industry aggregation update, as you can see over there on line 5, and the naming of this Delta table on the right-hand side. The latter half of the cell over here is just used to pull that data and to display it, just to make sure that it's all good, and give the developer, or in this case, the presentation of the people watching this, a sense of what was done. So here you can see that the sectors all been, the market cap for each of these sectors have been aggregated, and we're essentially left with 5 sectors for our portfolio, as well as the market cap for these. Now, what to do with this data? This is essentially a snapshot of the day's positioning for this portfolio. Well, we want to essentially add this to a larger data set that has held all the previous days' market caps per sector. So before we do that, little tangent here, you can actually also view the Delta table itself in Databricks. By going to Databricks, on the left-hand side, you have the Data tab. Select that and kind of follow the path as to where you set that Delta table, and you're able to see the information that you have here. Now, looping back, we're going to upsert this table that has today's positions into a second Delta table that has the historical positions for our sectors. And with that upsert, we use that by leveraging Spark as well. And we upsert the one data table, or Delta table, into the larger Delta table that contains the historical information. And that main Delta table is then fed into Tableau. So creating a connection with Tableau within Databricks is fairly straightforward. You're able to open up the actual cluster within Databricks, go to configuration, open up advanced settings. And then from here, you're able to get both the server host name as well as the HTTP path. And you'll need both of these in order to actually create that link within Tableau. And within Tableau, you can see on the right-hand side over here, we input that server host name, the HTTP path, as well as specify the personal access token that we have as the secret for that. And then we're able to access that Delta table directly from Databricks onto Tableau. And here we just have a quick little graph that just shows the allocation for each sector within a portfolio for that specific day. Now, let's kind of take a step back and focus on the notification aspect. How do we, the client now is able to see their holdings. They're able to have a understanding of, where is their money, which sector is their money in. And from that, we can also pull another information into the Delta table and create more visuals. But let's dive more so into the monitoring aspect. Give the client a sense of security. What if something happens with 2 other stocks in their portfolio? What if it tanks, or what if it increases tenfold? Enable them to actually be able to see that, and give them that guarantee that they will be notified in a timely manner. And this is how Airflow can leverage the email aspect of it by taking that value, or taking the data from Databricks, throwing it into Airflow, running some transformations within Airflow, and then dictating essentially whether or not it actually send information out or not. The information doesn't actually change, and therefore it does not require, or does not merit an email. So here we have the Databricks, and we have a few cells where you see the purple box at the very top. We're going to retrieve today's stock prices from the Yahoo Finance API. With today's stock prices, we're also going to retrieve a second data set, and we're actually going to call in a Delta table that has historical stock prices. And then we're going to retrieve yesterday's stock price as well. And this Delta table is essentially updated each day. So let's say today I run this job, it takes today's stock prices, and also appends that to this Delta table. So it's done every single day, and this Delta table contains the historical stock prices. So we retrieve yesterday's stock price, and then we have today's stock price. We determine that, or we calculate that percentage change in the stock price. And then we determine, quote unquote, the big movers. And these would be stocks that are arbitrarily set or captured based on an arbitrarily set threshold. Whether or not you want to be notified for stock changes that are greater than absolute 5%, greater than absolute 10%, so forth, so on, depending on the risk tolerance of the client. So here we have it set to 5%. So essentially any stocks that change in price for the day, and that change of price is greater than 5%, they are then pushed out of Databricks using this specific function over here. And when Airflow runs this Databricks job, we're also able to utilize a Databricks hook to essentially swing in and capture this output from Databricks and throw it into Airflow. So we're pushing those big movers out of Databricks into Airflow. And now we're going to ingest it, and now we're going to figure out how to actually capture this data. And we do that by, like I briefly mentioned, we use a Databricks hook. So as you can see in that top little snippet over here, we have a task function where we use the Databricks hook, and we essentially feed it, or the variable that we give it is the Databricks job ID, or the run ID. And from that, we retrieve a JSON, and we parse that JSON by retrieving the notebook output, and then retrieving the result of that notebook output. And this result will then contain that big movers data over here that's been pushed from Databricks into Airflow. And now this data will then be saved or thrown into the variable retrieve Databricks output. Then what to do with this output? What do we do to work with it? Well, we essentially want to set or have a clause where if there's actually data here, if there were big movers for this day, send out an email. If there weren't any big movers, then don't do anything. No email needs to be sent. Nothing relevant happened within your portfolio. So now we can use the branch Python operator to essentially invoke this clause statement. So as you can see in that top little snippet, with the task entitled branching, uses the branch Python operator which essentially, as mentioned, it splits or it enables us to essentially throw in a if-else statement with this specific example. And it's pushing that data into the data from Databricks into this if statement, which is the second little snippet here. And essentially, if there is no data, if the table returned was blank, then no email needs to be sent. So return no email required, which is assigned, which is the name of a dummy variable that is not in the slide, but it's a dummy variable that just does not contain anything. However, if there actually is data, then call upon the send email task, which is this task over here. And what this task is that it's attached to the email operator, which, like I kind of mentioned in the two, it sends out an email. And the subject of this email, Daily Movers, has the body of retrieve Databricks output. So in summary, we essentially pull this data from Databricks, throw it into Airflow. Within Airflow, transform that data a little bit. If that data actually has information in it, or if it was not blank, then use the branch operator to call upon this mail operator. If that actual data was blank, there's nothing there, then do nothing. And that's how it works. And here we have kind of a layout of the tasks and a little copying over that previous visual you saw, the graph at the bottom. So we have the run Databricks job, which runs the Databricks job, as well as feeds in parameters into Databricks. The retrieve Databricks output, which was that Python task, which takes that Databricks data that was sent out within Airflow and then puts it into Airflow, transforms that data. And then branching, which then decides based on that data if an email should or should not be sent. And then based on that, we either invoke the no email, which is that dummy operator, or mail, which is that email operator, and go on from there. And that's pretty much all the technical stuff associated with this. I will hand this over off to Shantana as well.
Thanks, guys. There was a lot of great information in there. Super interesting to see that use case implemented. I think we do have a couple of additional questions that we haven't gotten to in the chat yet. The first is, when would you choose to orchestrate your pipelines with Airflow instead of using Databricks workflows?
Yeah, that's a very good question. In my opinion, Airflow allows the user to retain more control over the workflow. So if your workflow, especially if your workflow is going to involve a number of different tools and they have to coordinate, I think that's one of the areas where Airflow really shines. So so you can have an architecture where you have a central player, Airflow, for communicating with and administrating between the different tools, rather than a workflow where there are dependencies set between individual tools, which tends to be more finicky. So that's one of the main reasons in my experience. Also, Airflow scheduling and how you approach failed tasks and retries, etc., extremely dependable. So that's another strength. Yeah, and then setting up connections on Airflow, again, going back to the first point, is really straightforward. And that actually, I think, is a good segue to another question. And of course, Kenton, if you want to add to that, feel free. But Abhishek also had a question around how do we actually set up that connection between Databricks and Airflow. So I'll take a second here to show that. Okay. So in Databricks, if you go to settings and user settings, one of the tabs up here is access tokens. So you can generate an access token from here. That's all you will need to do from Databricks' side. So I have an Airflow connection named token that I generated here. This is the astronomer UI for this DAG that we showed you. And here you can open Airflow from here. If you want to go to the Airflow console. Within the Airflow console, you can usually you end up in the DAGs view. But if you go over to admin and connections, then you create a new connection. And here you can pick Databricks from this drop-down menu. And in the extra section, you need to pass it the token that you generated in Databricks. There are a couple of other fields that you have to fill in, but it's really straightforward. I'm not going to share the connection that I made just because actually it's just a token. I think it should be okay sharing it briefly. So yeah, the host address, selecting Databricks, giving it a name, and then just the token information. That's all that it's needed. And now Airflow knows your Databricks workspace.
Awesome. Thanks for that, Shantanu. We have another question asking about the branching. So Amir, the piece you showed in kind of the last slide, someone was asking for more details on how that output is generated. So maybe you can talk a little bit more detail briefly about how that branch operator works and sort of what.
Sure. Yeah, no, that sounds good. Here, I will share my screen once again here. Give me a quick second. Okay, yeah, so yeah, we can talk about the branching right now. So let's take maybe just another step back and fall back into actually pulling that data from Databricks, throwing it into Airflow, and assigning that to a variable. In this case, the variable name is retrieve Databricks output. So this is the variable that contains the whatever data was in Databricks. And let's start from here. So we have this variable. We go into the branching or the branch Python operator. So within this operator, what we do is we essentially call upon a function. So we use the branch operator to let Airflow know that there's going to be a branch. And within this branch, we're going to be essentially working with a specific, sorry, let me rewind a little bit here. So within the branch Python operator, we call a Python function, and we also specify the data that we're going to be working with. So in this case, it's going to be the retrieve Databricks output, which is this data that was aforementioned here. This is the data from Databricks. So from branching, we call this function called split. And split is kind of it contains a logic for the branch. So the data retrieved Databricks output will have two different types of data. It'll either have a string called no email required, or it will have something else, which in this case, the something else will be a stock or a ticker of a stock with a percentage change that's greater than that threshold that was set in Databricks. So it calls the Python callable split, which contains the logic. If there is no data, so therefore if it's no email required, then essentially do nothing. What this does is that it prints this out. It should then be captured within Airflow logs. So someone looking at this can then take a look at this and see this is what happened during this run. There are no big movers. And within the return, you're able to return essentially another operator. So within this logic, we talk about two different operators. We either return no email required, which, like I kind of mentioned, that no email required is the name for a dummy operator. And a dummy operator just does nothing. I can kind of dive into my code here a little bit and show you. Are you guys able to, let me stop sharing to share my screen as a whole. We'll just be. Okay, so this is the code, and we'll also be posting this up as well, I believe, with the branching operator, calling that split function. And the function for split is up at the very top over here. And this contains the logic. If there's no data, return this operator. If there is data, return this operator. So the no email required operator is this one over here. And it's a dummy operator, nothing happens. It just ends the DAG then and there. Within the opposite side of that logic, if there is actual content within that operator, or within the data that's from Databricks, this operator is uninvoked, which then creates that email and sends out that email with the data as the body. That kind of makes sense in this case. And Shantana maybe might be able to explain this a little bit more elegantly than I did.
I think you did a great job.
Oh, thank you.
Yeah, just like the Python operator, the branch Python operator can take a Python callable, which is a Python function.
And we just had a follow-up question on what is the dummy operator doing in this case. So in general, when you use the branch Python operator, you have to have two branches to follow, no matter what. So you can't say just do nothing. So the dummy operator is a way of implementing just do nothing in one part of your branch. So if your branches do this in this scenario, but not in these other scenarios, it's just the way of saying not to do anything. So you have to put that operator in there. Great questions. Don't think I see any others that we haven't gotten to, but in case I missed something.
There was one from Benjamin. Do you use a service principals to connect with Tableau to not use our personal token? So Databricks does have a partner connect with Tableau specifically, and you can just configure it with your single sign-on, so you wouldn't have to worry about personal tokens if you did it that way.
In general, with Airflow connections as well, there are usually ways to get around using tokens depending on how your Airflow infrastructure is set up and what other tools you're using. So those are often kind of the lowest hanging fruit for the easiest way to set that up. But sometimes within organizations, those aren't allowed or they're not the best sort of case for, working in broader teams. So they're very rarely the only way that you can connect Airflow to some other service. And then I think one last question on just popped up on where Astronomer comes in. So Astronomer is going to make it much easier to run Airflow at scale. We're happy to chat more about that with anybody who wants to. Feel free to reach out to us. We'd love to hear from you, but all of these things, so managing your Airflow connections and different Airflow environments, or he asked about having, a separate Airflow environment for a team of analysts. That's all stuff that Astronomer is going to make sort of available to you without having to deal with all of the underlying infrastructure. So really big help there. But like I said, if you're interested in hearing more about that, definitely reach out to us. See.
Airflow web server is run in Astronomer or in the Docker container. Kenton, I believe.
Yeah, so the question on where the Airflow web servers run totally depends on your Airflow infrastructure. So if you are running Airflow in a Dockerized setup, which we highly recommend, that's the most common way, then yes, your web server would be in its own container. If you're running Airflow like on a local computer with Docker, you would have an actual container there. If you're running on Astronomer or another managed Airflow service, you're likely going to be in some sort of cloud service. So Astronomer runs on Kubernetes, so your web server will be in its own pod there. Other services kind of differ in what that looks like.
And then to Benjamin's last question. So in this workflow that we demonstrated, the Delta table is actually abstracted away from Tableau. So we just connect Tableau to Databricks and it sees the Delta table in Databricks's database. We haven't done a direct port over of a Parquet or any other kind of file to Tableau yet. We are, if that's something that you think would be useful, we can certainly write a example workflow where we do that and add it to the Astronomer registry. Awesome.
Well, thanks to everybody for joining, and thank you so much, Shantana and Amir. This was really great. Love being able to spend some time focusing on, again, outside of the normal data engineering stuff that we talk about. So love seeing Airflow in this use case. Again, thanks everybody for joining. You'll see the recording and other materials pop into your inbox soon. And I'll also throw out there that be on the lookout for information about our upcoming webinar in 2 weeks from now. We are going to be talking about new Airflow 2.3 features. Airflow 2.3 is forthcoming. I'm super excited about it, much awaited, and sort of some big paradigm shifts in DAG authoring that you definitely won't want to miss. So be on the lookout for that, and we hope to see you all soon. Have a great rest of your day.
Thank you all.
Everybody.
Everyone. Thanks, guys.